Hello dear students, welcome to the session. In this session, we'll learn some MCQ problems on binomial theorem. Before that, points to remember, these are the very important points. Actually, in this chapter, many formulas are there. Those are called time-saving formulas. But I am not going to give all the formulas because remembering all the formulas will be little difficult. So instead of that, if it is possible with the method, we'll go with the method. Okay, but these are the important ones. You have to remember, there is no other option. Okay, see the first one. The coefficients of r plus 1 and r plus 2 term of the expansion 1 plus x whole to the power n. We know the expansion of this, right? 1 plus x whole to the power n will be nc0 plus nc1x plus nc2x square till ncn x to the power n. So this is the expansion are in AP. For example, second, third and fourth terms are in AP. Then this formula will be useful. N square minus 4r plus 1 into n plus 4r square is equal to 2. So by using this, we can find the equation. So you have to remember this. For example, 3 terms are in AP. 5th, 6th, 7th. Or 8th, 9th, 10th, 3 terms are in AP, then we can use this formula. Okay. Second one is to find the greater term in the expansion of 1 plus x whole to the power n. First, we need to find the value of k. Okay. The formula is given by k is equal to n plus 1 x divided by 1 plus mod x. Here n will be there, right? So plus 1 multiplied with the x divided by 1 plus mod x. It may be a negative or positive, but here we'll be considering this as positive. So that we'll get the value of k. Is it clear? This is applicable only for the expansion of 1 plus x whole to the power n. So after getting the value of k, see here, x may be anything, right? So the value of the k, suppose if it is an integer. See, I'll write here, suppose k is an integer, then directly what we can say, tk and tk plus 1 are equal and those are called the greater terms. If it is k is an integer. Suppose if k is not an integer. For example, if you get the value of k as 5.6. Okay. Now this is not an integer, but this can be written in the form of m plus l. See here, I have taken here k is equal to m plus l. M plus l is nothing but this is 5 plus 0.6. Okay. So the value of l is always between 0 to 1, less than 1. So 5 plus 0.6. So the value of m will be equal to 5. So that is nothing but m plus 1th term is the greater term. Simple, no need to worry about that. So if it is 5.6, then the term will be a 6th term. Next term you have to take. You are not supposed to come back. Is it clear? If I say 8.9, so 8.9, so can be done as 8 plus 0.9. So m plus 1 means this is the next to of this one. So it will be 8.9 is very close to 9. So it will be 9. If it is 8.1 also, the greater term will be the 9th term. Okay. In this way you can remember. Remember, to find the greater term, the formula is n plus 1 into x divided by 1 plus mod x. This is always positive. It may be a negative or positive. This will be positive. Okay. If it is k is integer, then that will be the greater term. If it is k is not an integer, then you have to go next to that number. So it will be the greater term. This is also very important one. To find the greatest coefficient. See the difference. This is a greater term. This is the greatest coefficient in the expansion of 1 plus x whole to the power n. nc n by 2. If n is even. Suppose this number n is even. Then the greatest coefficient will be nc n by 2. Okay, if it is n is odd, then the number will be odd, can't be divided by 2, right? So once either you can subtract or you can add. So this will be c nc n minus 1 divided by 2 or nc n plus 1 divided by 2. These both the terms will be equal. For example, if it is of the form 1 plus x whole to the power 8. Okay, then the greater coefficient will be 8 by 2. That is the fourth. Okay. Now, if it is 9 is there. For example, this is of the form 1 plus x whole to the power 9. So, odd number. So, what we can do? 1 is 9 minus 1 by 2. Another one is 9 plus 1 by 2. NC2. Okay, 9C. Even here 9C. So both the terms will be equal. So no need to find both. You can find any one. Either NC n minus 1 by 2 or NC n plus 1 by 2. So this will give you the greatest coefficient. Okay, I erase this point. The number of terms in the expansion of x plus a whole to the power n minus x minus a whole to the power n. Here you can see, here n plus 1 number of terms will be there. Even here n plus 1 number of terms will be there. Here in this alternatively positive and negative signs will get. Right? It is multiplied with a negative sign. So few terms will get cancelled. So if it is, this is the form, then the number of terms will be n by 2 if the number n is even, and n plus 1 by 2 if the number n is odd. Is it clear? So in this expansion, if n is even, then n by 2 number of terms will be there. If it is n is odd, then n plus 1 by 2. In the expansion of x plus a whole to the power n plus x minus a whole to the power n. Here x plus a whole to the power n minus, here it is plus. Even here some terms will get cancelled, because in this expansion will get alternatively positive and negative signs will be n plus 2 by 2 if n is even and n plus 1 by 2 if n is odd. These are the two very important points to remember. Remember this and note it down. Okay, now we'll solve MCQs. The term containing x cube, okay, the term containing x cube in the expansion of root x to the power 5 plus 3 by root x cube appears in which term? Option A, third, fifth, sixth or fourth term. First try to understand the question. The expansion is given this one, right? You are finding the term containing x cube. For that we need to find the value of r, right? So if you get the value of r, then the tr plus 1 will gives you the term, right? Let us start that. First value is the formula tr plus 1 is equal to nc r a to the power n minus r into b to the power r, right? So this will be the value of n is given here 6, c, r is, we don't know, we have to find the value of a is root x to the power 5, yes, whole to the power 6 minus r into 3 divided by root x cube whole to the power r. Is it clear? Just I have substituted a as root this one and the value of b is this one and the value of n is equal to 6. Now we have to find the term x cube. For that we need to simplify this. See here, root x to the power 5 is there and here root x cube is there. So this is equal to 6cr x to the power, I can write this as 5 by 2, right? Root of x to the power 5 can be written as 5 by 2 whole to the power 6 minus r into, I'll split this one, see, 3 to the power r into 1 divided by root x cube can be written as x to the power 3 by 2 whole to the power r. Is it clear this step? See, this is root x to the power 5 can be written as x to the power 5 by 2, right? Root x cube can be written as x to the power 3 by 2. Now we'll collect the terms in x because we have to find the term containing x cube. So we'll collect the terms. So this will be 6cr as it is. So x to the power will multiply 5 into 6 will be 30 minus 5r divided by 2 and I'll write this term 1 divided by, see, x to the power 3 by 2 whole to the power r, I can write 3r divided by 2 into 3 to the power r. This is as it is, right? So this will be equal to now 6cr x to the power, see here, 30 minus 5r divided by 2. When this goes up, it will be minus 3r divided by 2. Agree? Just I have collect the terms in a x. See, x to the power 30 minus 5r divided by 2 as it is. 1 divided by x to the power 3r by 2. When it goes up, it will be x to the power minus 3r by 2. So bases are same. You can collect the powers, right? And into 3 to the power r as it is. So this will be now 6cr x to the power. We'll take the LCM. LCM is 2. So 30 minus 5r minus 3r will be 30 minus 8r, right? And into 3 to the power r. Now what we can do here? We need the term in x cube. So this 30 minus 8r divided by 2 should be equal to 3. So that we'll get the value of r, right? So the question is the term containing x cube. So we need this as 3. Yes, let us take this one. See here. 30 minus 8r divided by 2. Here we can take, this should be equal to 3, right? Here you can take 2 common. So it will be 15 minus 4r, right? Should be equal to 3. So here 2 and 2 will get cancelled. Is it clear? I'll take 2 common so that it is 15 minus 4r. So this and this will get cancelled. So now we'll simplify. 15 minus 3 will be equal to 12 is equal to 4r. So the value of r is equal to 3. Yes. So the r is equal to 3. So this will be the T4. Right. R is 3. 3 plus 1 will be 4 is equal to. So this will be 6C3 and x to the power. Anyway, substitute as 4. So it will get it as cube and 3 to the power 3. So this is x cube appears in the fourth term. So answer is D. The coefficient of x to the power 4 in the expansion of x divided by 2 minus 3 by x square whole to the power 10 is. So we are finding the coefficient of x to the power 4 in this expansion, right? Similar to the previous problem, just first we'll write the general term TR plus 1 is equal to, here I am not going to write the formula, directly I will write 10, see the value of n is 10, r, right? In the place of x we will be having x divided by 2 whole to the power 10 minus r into the value of y will be minus 3 by x square, right? So minus is important here. Minus 3 divided by x square whole to the power r. So we need the coefficient of x to the power 4. So for that here two x's are there. So we'll collect the terms in x. So this is 10 cr, right? X to the power 10 minus r divided by 2 to the power 10 minus r into this is minus 3 to the power r, and this will be 1 by x square whole to the power r. So in this step also you can write directly. It will be 10 cr x to the power, I will collect x to the power 10 minus r, and here x to the power 1 by x to the power 2r. So when it goes up it will be minus 2r, right? Remaining with 1 divided by this is as it is 2 to the power 10 minus r into minus 3 to the power r. So now this is 10 minus r will be, I can write this is 10 minus 3r, right? So this should be equal to 4 because we have to find the coefficient of x to the power 4, right? So this will be now x to the power 10 minus 3r should be equal to x to the power 4. That is nothing but 10 minus 3r is equal to 4, right? 10 minus 4 will be 6 is equal to 3r, and the value of r is equal to 2. Is it clear? Now we got the value of r. Just substitute here so that we will get the coefficient. So r plus 1 is nothing but T3 is equal to 10. See the value of r is equal to 2, and x to the power 10 minus 3r will be 3 into 2 will be 6, right? 10 minus 6 will be 4. So we need to find the coefficient of that same. So 1 divided by 2 to the power 10 minus r will be 8 minus 3 to the power 2. Is it clear? Now, so the coefficient of x to the power 4. What is the coefficient of x to the power 4? 10 C2 1 divided by 2 to the power 8 and minus 3 square will be 9 into x to the power 4. So this is the coefficient of x to the power 4. We have to, this is not there in this form, right? So we have to find the value of this. Just simplify this. 10 factorial divided by 10 minus 2 will be 8 factorial into 2 factorial. 1 by 2 to the power 8. Find the value. Multiply with 9. So that you will get the coefficient of x to the power 4. And answer you have to get it as 405 divided by 256. Okay. So this is the answer. Okay. Verify your answer. Answer should be 405 divided by 256. If the coefficient of x in the expansion of x square plus k by x whole to the power 5 is 270. Coefficient of x in this expansion is equal to 270. Then find the value of k. You have to find the value of k. Options are 3, 4, 5, 2. Let us check with this. So here also anyway you are finding the coefficient. So you have to go with the general term. So TR plus 1 is equal to n. The value of n is 5 CR, right? X square to the power 5 minus r, k divided by x whole to the power r. Now we need the coefficient of x. So this can be written as 5 CR. Yes, x to the power 2 into 5 is 10 minus 2r. Directly see here, this is 1 by x to the power r. So directly I can write as minus r. Yes, similar problem we had solved. So this is remaining with k to the power r. So this is TR plus 1. Now see here, we got that as x to the power 10 minus 2r minus r will be 3r. We are finding the coefficient of x. So this should be equal to 1. Right? Then only we'll go to the coefficient of x. So we'll equate 10 minus 3r should be equal to 1. 10 minus 1 will be 9 is equal to 3r. The value of r is equal to 3. So half of the work is done. We got the value of r. Now just you have to find the value of k. So this will be T4, right? 3 plus 1 will be 4. 5C3 x to the power, substitute r as 3. Anyway, we'll get it as 1 because we are finding the coefficient of x. And this is k to the power r is 3. Now coefficient of x. What is the coefficient of x? 5C3 and k cube, right? Coefficient of x is 5C3 and k cube, and it is given that 270, right? So we'll equate that. Is it clear? So coefficient of x is given. Here we got coefficient of x as 5C3 k cube. This is the coefficient of x and it is given as 270. We'll substitute into k cube is equal to 270. Now we need to simplify. So I can write k cube is equal to 270, right? Divided by 5C3. So this is 270 divided by 5 factorial, right? 5 minus 3 will be 2 factorial into 3 factorial. Yes, we'll simplify that. So this is now is equal to 270 divided by 5 factorial will be 5 into 4 into 3 into 2 into 1. When this goes up, it will be 2, and this is 3 factorial will be 3 into 2, right? We'll cancel few things. We'll get cancelled. 2, and this is 2, right? 5, this is 5. So this is 2, so it will be 4, right? 2, and this is 2 and 27. So this is equal to k cube, right? K cube is equal to 27. So what is the value of k? Obviously 3 cube will be equal to 27. So the value of k will be equal to 3. So option A. I hope you understood this problem. Question. If A and B are coefficients of x to the power n, okay, A and B are the coefficients of x to the power n in the expansion of 1 plus x whole to the power 2n and 1 plus x whole to the power 2n minus 1, then A by B is it clear? A is the coefficient of x to the power n in this expansion and B is the coefficient of x to the power n in this expansion. Then the value of A by B is, okay, first what you have to do, first we'll find the value of A, okay, then we'll find the value of B, then we'll find the ratio. So first we need to find the coefficient of x to the power n in this expansion. So similar to that previous one, TR plus 1 is equal to the value of n. What is this? Is n is 2n, right? 2n CR 1 to the power, no need to write. So this will be x to the power r. I need the coefficient of x to the power n. Here I got x to the power r, right? To get the coefficient of x to the power n, what we have to do? Just we need to substitute r is equal to n, right? Agree, put r is equal to n. So what we'll get? Tn plus 1 is equal to 2n Cn x to the power n. So what is the coefficient of x to the power n? Will be 2n Cn. Yes. So this will gives you the value of A. So this is the value of A. So similarly, we'll find the value of B. Here the value of this is, you can, in this expansion we will be finding the value of B. So it will be 2n minus 1 CR, right? 1 to the power n, then x to the power r. Here also, to get the value of x to the power n, we have to substitute r is equal to n. Is it clear? So this will be now 2n minus 1 Cn x to the power n. So what is the coefficient of this? 2n minus 1 Cn. So what we got? The value of A is equal to 2n Cn. This is the coefficient of x to the power n in this expansion. And the value of B is equal to 2n minus 1 Cn. This is the coefficient of x to the power n in this expansion. Now we'll find A by B. So here I'll write A by B will be equal to 2n Cn divided by 2n minus 1 Cn. Right? We'll use the formula. It will be 2n factorial divided by 2n minus n will be n factorial into n factorial whole divided by, this is now 2n minus 1 factorial divided by 2n minus 1 minus n will be n minus 1 factorial into n factorial. So simplification will be easy. Now we can cancel n factorial, right? Here see 2n factorial is there, 2n minus 1 factorial. So 2n minus 1 factorial can be get cancelled. So what is remaining? 2n. So clear? Directly I'll write, because you know this. Here n factorial divided by n minus 1 factorial. So that I can cancel n minus 1 factorial. So we will be remaining only with n. Right? So we'll be remaining with n. Now what is remaining? 2n divided by n. So we can cancel n and n. So the value of A by B will be equal to 2. That is the option B. Is it clear? Just what you have to do? You have to find the coefficient of x to the power n in this expansion. Then coefficient of x to the power n in this expansion. Then you have to divide. Okay. If the coefficients of second, third and fourth terms in the expansion of 1 plus x whole to the power n are in A. It is in an arithmetic progression. You know what is arithmetic progression, right? Then the value of n is, we had one formula, right? If it is r plus 1 and r plus 2 term is in AP, then we have one equation, right? By using that equation, we can find the value of n. And here the value of r is equal to 2, right? What is that equation? Equation will be n square minus 4r plus 1 into n plus 4r square is equal to 2, right? So this is equal to n square minus 4r is 2, 4 into 2 is 8, 8 plus 1 will be 9. So this is 9n plus 4 into r square, 2 square will be 4. So 4 into 4 will be 16 is equal to 2. So we got the quadratic equation. We'll simplify. N square minus 9n plus 16 minus 2 will be 14 is equal to 0, right? So sum should be 9 and product should be 14. Obviously 7 and 2, right? So n square minus 7n minus 2n plus 14 is equal to 0. We can take n common, n minus 7. So this will be n minus 7. So we have to take minus 2. So minus 2n plus 14, right? So we got this as the value. This you can write as n minus 7 into n minus 2 is equal to 0. That means the value of n is equal to 7 or 2. What is the value now? N is equal to 7 or 2. Both the options are there. A is 2 and the value of B is 7. Which one we have to consider? Here you need to think. Is it 7 or 2? See, if it is a value of n is equal to 2, what happens there? It will be 1 plus x whole square. Right? Whole square means how many terms will be there? Obviously 3 terms. Right? 3 terms. 2 is there, so 1 more than that. 3 term. Means first, second and third. But in this question it is given that second, third and fourth. To get second, third and fourth term, we have to substitute n equal to 7. Right? If you substitute n equal to 7, the number of terms will be 8. So that will get second, third and fourth. So n equal to 2 is not possible. So the answer n equal to the total number of terms. So we are finding the total number of terms in the expansion of x plus a whole to the power 100 plus x minus a whole to the power n after the simplification is. So we know the formula for this, right? If it is of the form x plus a whole to the power n plus x minus a whole to the power n. Another one formula is for x plus a whole to the power n minus x minus a whole to the power n. Right? What is the formula? If it is the form x plus a whole to the power n plus x minus a whole to the power n. So here two conditions are there, right? If n is even, then the number of terms will be n plus 2 divided by 2. And if it is n is odd, then the number of terms will be n plus 1 divided by 2. Right? Here we can see this. This is 100. Here both the side it should be same. So it is n is even. So total number of terms will be n plus 2 divided by 2. So n plus 2 is nothing but 100 plus n is 100. Right? Here n is equal to 100. It is an even number. So 100 plus 2 will be 102 divided by 2. So will be equal to 51. So the option C. Is it clear? Simple question. But this type of problems are very important. This was appeared, okay, in the CET exam. Problem. I think you can try this problem. The ratio of the coefficient of x to the power 15 to the term independent of x. Is it clear? You are finding the ratio of the coefficients of the x to the power 15 and term independent of x is nothing but x to the power 0 in the expansion of x square plus 2 by x whole to the power 15 is. Options are 12 is 32, 1 is to 32, 32 is to 12 or 32 is to 1. Now let us check with this. First, what is the expansion now? NCR. What is the value of n? Is 15, right? TR plus 1 is equal to 15 CR. Right, this is x square is there. So x square to the power 15 minus r into 2 divided by x whole to the power r. First we'll collect the terms in x. Okay. After that we'll find the coefficient of x to the power 15 and term independent of x, so that it will be easy. So this is now 15 CR. Right, x to the power 15 into 2 will be 30 minus 2r, right, and here x to the power r is there, so this will be minus r into 2 to the power r, right. So this is equal to 15 CR x to the power 30 minus 3r into 2 to the power r. Now we need the coefficient of x to the power 15. So that is nothing but here will equate 30 minus 3r should be equal to 15. So 30 minus 15 will be 15 is equal to 3r and the value of r is equal to 5. So that we'll get the coefficient of x to the power 15. So we'll substitute r is equal to 5. Right? If you substitute r is equal to 5, this will be T6 is equal to 15 C5 x to the power 15 into 2 to the power r is 5. So the coefficient of x to the power 15 will be, what is the coefficient of x to the power 15? We got it as 15 C5 2 to the power 5. So this is the coefficient of x to the power 15. Now we have to find the coefficient of term independent of x. Right? I don't have place here. I'll erase this first. See here, I have written the coefficient of x to the power 15 here. 15 C5 2 to the power 5. Now the term independent of x is nothing but 30 minus 3r should be equal to 0. Right? So 30 is equal to 3r. So the value of r is equal to 10. Right? We'll substitute r as 10. So that this will be equal to 15. C, r is 10 now. X to the power 30 minus 30 will be 0. And 2 to the power 10. So the term independent of x, this is the term is independent of x because x to the power will be 0. What is the coefficient? 15 C10 into 2 to the power 10. So this is the coefficient of the term independent of x. Now we have to find the ratio. So we'll divide those two. So this is now x to the power 15 to this. Okay, see the question. The ratio of the coefficient of x to the power 15 to the term independent of x. So this is now 15c5 2 to the power 5 whole divided by 15c10 2 to the power 10. Right? Now can I cancel these two? Yes. Here 15c5 is there. 15c10 is there. Can we cancel? If you want, you can check. See, this is 15 factorial. So 15 minus 5 will be 10 into 5 factorial. This is 15 factorial divided by 15 minus 10 will be 5 into 10. Or we have the formula, right? Do you remember this? NCR is always equal to NCN minus R. By using this formula also we can cancel this. Or you can simplify and check. 2 to the power 5 and 2 to the power 10. So this will be 5 is nothing but 1 divided by 2 to the power 5. 1 divided by 2 to the power 5 is nothing but 1 divided by 32. So the ratio, this will be 1 by 2 to the power is nothing but 1 divided by 32. So the ratio will be 1:32. So option answer is B, 1:32. I hope you understood this problem. Question. The coefficients of x to the power p and x to the power q in the expansion of 1 plus x whole to the power p plus q are. Simple problem. Actually, you can try this problem. So options are given. Coefficients are equal with opposite sign. Option C is reciprocal to each other. D is none of these. So first we'll write the general term. So what will be the TR plus 1 will be? Now n. In the place of n we'll be having p plus q. Right? P plus q, C, R and x to the power r. Yes. Now to find the coefficient of x to the power p, what we have to do? We have to substitute r is equal to p. Right? So if I substitute r is equal to p, so this will be now p plus q. Right? C, R is p, x to the power p. What is the coefficient of x to the power p now? P plus q, C, p. So this is the coefficient of x to the power p. Now I need to find the coefficient of x to the power q. Right? To find the coefficient of x to the power q, what I can do? I can substitute r is equal to q. Is it clear? We are finding the coefficient of x to the power p and x to the power q in this expansion. So this will be r is equal to q means p plus q. C, the value of p will be now q, right? X to the power q. So coefficient is this one. P plus q, C, q. Is it both are equal or equal with opposite sign? What will be the expansion of that? See, just to check with this one. P plus q, C, p. What is the value here? P plus q factorial divided by p plus q minus p. So that p and p will get cancelled. Q factor getting, just I am substituting the formula. NCR is equal to n factorial divided by n minus r factorial into r factorial. So this is the first one. So if I consider the second one, this is now p plus q CQ, right? So this will be equal to, this is n is now p plus q factorial, p plus q whole factorial divided by p plus q minus q. So that q and q will get cancelled. P factorial into q factorial. Check whether they are equal. P plus q factorial divided by this. This is also p plus q factorial divided by p factorial into q factorial. So both are equal, right? So the answer is option A. I hope you understood these problems. I'll send few more MCQ problems. Try to solve those. Okay, thank you.